Hello, good morning. I'm Ma'am Macer, your teacher in Earth Science. So for today, we're going to be focusing on topic number 2, which is all about earthquake belt. So before that, let's have first a simple recap on what have we discussed during our grade 8 discussion, which is actually way back 2 years ago, by which we discussed thoroughly on the entire year level, second quarter earthquakes. But this time we will be more focusing on earthquake belt. Okay, so let's discuss first, or let's define first, what is an earthquake. Earthquake is actually any sudden shaking of the ground caused by the passage of seismic waves or earthquake waves through the Earth's rocks. Seismic waves are produced when some form of energy stored in Earth's crust is suddenly released. Usually, when masses of rock straining against one another suddenly fracture and slip. Earthquakes occur most often along geologic faults. These are known as narrow zones where rock masses move in relation to one another. The major fault lines of the world are located at the fringes or on the boundary of the huge tectonic plates that make up Earth's crust. So don't worry, this discussion about plate tectonics, the dynamics of this tectonic plates will be discussed as we proceed to our next discussion. So, when rocks underneath the earth are subjected to different forces due to collision and interaction of plates, they bend or they adjust to these forces that surround them. Specifically, this is with respect to the behavior of rocks, with respect to the movement of the plates. But when the energy given by the forces exerted by these plates cannot withstand by the rocks, they snap and releases the energy in the form of waves, vibration, or also known as seismic waves. This was actually thoroughly discussed using the elastic rebound theory. So there are actually different types of seismic waves that we discussed during our grade 8 discussion. So brief recap, we have two types, the body waves and then the surface waves. The body waves are the type of seismic waves that can penetrate through the Earth's interior, whereas surface waves, these are actually most devastating and destructive, for it passes through and actually observed through the Earth's surface. So this type of seismic waves or the surface waves are the one which is actually felt and are actually causing some destructions through our Earth's surface. So under body waves, we have two classifications again. We have primary waves, or also known as the P waves. P waves can pass through all mediums such as solid, liquid, and then gases. As we do know during our previous discussions that our Earth's interior is highly made up of not only solid substances such as rocks, but likewise, it is also composed of molten substances in the form of magma. Okay, so through this type of primary waves, we could somehow look into the structure, properties, and characteristics of our Earth's interior, for it can pass through not only solid substances but likewise liquid substances such as magma. The next is actually the secondary waves. The secondary waves can pass through only solid mediums. So this is very significant. The property of the secondary waves is very significant, is that when the secondary waves cannot reflect any type of movement from the seismograph, it only means that the secondary wave passes through a liquid medium. So if it does not record, or if it does not bring any record to the seismograph, it only means that this particular region of the Earth's interior consists or composed mainly of liquid substances. So that's the main significant purpose of the secondary wave, for it passes only solid medium only. So correction on that, secondary wave passes only through solid medium. So next would be the fastest seismic waves are called primary waves, or also known as P waves. These waves are the first to reach any particular location, for it can pass through solid, liquid, and then medium, a gas medium. So these waves are the first to reach any particular location after an earthquake occurs. Primary waves travel through Earth's crust at an average speed of about 5 kilometers per second. So primary waves can travel through solids, liquids, and likewise gases. As they pass through a material, the particles of the material are slightly pushed together and pulled apart. So the type of movement of this particular seismic waves as they pass through the rock is that they try to compress or compact the rocks, and then likewise as they travel through, the rocks tend to expand again from its original form, size, or shape. So buildings also experience this push and pull as primary waves pass through the ground they are built on. So that's the primary effect of primary seismic waves on rocks and other infrastructures such as buildings. So push and pull, or compress and then expand. The second type, again, may I reiterate on this, secondary waves are the second seismic waves to arrive at any particular location after an earthquake. Though they start at the same time as primary waves, since it can only travel through solid medium, if this particular seismic waves passes through a liquid medium, the tendency is that it slows down, or much worse than that, there will be no record at all, for it does not, or it cannot travel through liquid medium. So there will be a delay, or totally a freeze on the record of the seismograph if and ever secondary waves passes through a liquid medium. That is why this secondary wave will just arrive shortly after the primary wave. So as they pass through a material, the material's particles are shaken up, down, or from side to side. So the movement of which the secondary wave is actually up and down. So secondary waves rock small buildings back and forth as they pass through. Secondary waves can travel through rock, but unlike primary waves, they cannot travel through liquids or gases. So surface waves. Surface waves are seismic waves that move along Earth's surface, not through its interior. They make the ground roll up and down or shake from side to side. Surface waves cause the largest ground movements and the most damage. So do not forget that, because they travel through the Earth's surface. So most of the damages to infrastructures, likewise some casualties, is actually brought by a surface waves. Although surface waves travel more slowly than other types of seismic waves, but this type of seismic wave bring much more damage than any other type of seismic waves. So to proceed with earthquake belts, again, we have three major geologic belts, namely the Circum-Pacific Belt, the Alpine Belt, and then the Mid-Atlantic Belt. So to begin with, the Circum-Pacific Belt is actually the most largest earthquakes zone which occurs around the coast of the Pacific Ocean. Earthquakes originate mostly beneath the ocean floor. The intense and widespread ones occur near the coast. So to those people who are living near bodies of water, they are the ones much affected if there is a movement of crust on the bodies of water. So if and ever this particular location is designated as an active area for earthquake, it is much advisable for them to go or to evacuate immediately or totally vacate the area if and ever this particular location is under an active earthquake fault zone or fault area. So next would be, this belt accounts for the largest earthquakes in the world. So we do know that most of the, based from our discussion on volcanic belt, this particular belt is actually the most active, for it created the most active volcanoes in the world. Thus, most of the earthquakes, which is under the category of damaging in terms of casualties, it produces the most of casualties. This accounts to this particular Circum-Pacific Belt. For this one is the most active type of geologic belt. To begin with, or to have a specific example, let's take here our country, which is part of the Circum-Pacific Belt. Way back 2013, Bohol Island was hit by a 7.2 magnitude earthquake, and it leaves 158 people dead right at that very moment. Looking on the figure on the topmost portion, as you can see, the whole road area of this particular part of Bohol is actually damaged, and as you can see, cracks and fissures are created on this part of the road. This is again way back 2013 earthquake, Bohol, Cebu, 7.2 magnitude earthquake. And as you can see on this picture, residents walk past a damaged structure in Cebu, Central, Philippines on Tuesday, October 15, 2013. Again, it has a magnitude of 7.2 and struck in the Central Philippines on Tuesday morning, collapsing roofs, buildings, cracking the walls, and other infrastructures. And again, on this picture, the 7.2 earthquake was centered about 35 miles below Carmen Town on Bohol Island. Next would be this one. Following our news articles about the devastating earthquake that hit Baguio City way back July 16, 1990. The picture is actually the Hyatt Hotel, wherein it was newly constructed. This was actually built during the period of our late president, which is Ferdinand Marcos. But then again, due to this earthquake way back 1990, it totally damaged and collapsed the whole Hyatt Hotel. Next would be the earthquakes in the Alpine. belt. So again, the Alpine belt focuses on the European and then some parts of the Asian continent. So extends along the Alpine mountain range of Europe, North Africa through Asia Minor, Caucasia, Iran, Afghanistan, and Pakistan to the Himalayan mountain range. So do not forget the scope of the Alpine belt. A second belt known as the Alpine belt passes through the Mediterranean region eastward through Asian continent and joins the Circum-Pacific belt in the East Indies. But then again, most of the concentration of the volcanoes, earthquake occurrences focuses merely on the European continent and some extends to the Asian continent. So the energy release in earthquakes from this belt is about 15% of the world total. There are also striking connected belts of seismic activity, mainly along oceanic ridges, including those in the Arctic Ocean, Atlantic Ocean, Western Indian Ocean, and along the reefs of East Africa. This global seismicity distribution is best understood in terms of plate tectonic setting. So as we do discuss during our volcanic belt, this type of Alpine belt is active due to the plates that are likewise active underneath it. Okay? So the mountains of Myanmar, China, Eastern Siberia are still part of this Alpine belt. Records of shallow earthquakes from 70 to 300 kilometers from the Earth's surface are actually recorded from the Alpine belt. Next, and the very last type of earthquakes in the mid-Atlantic belt, earthquakes in the geologic belt is the mid-Atlantic belt. So as shown on the picture, this one is the mid-Atlantic belt. This earthquake belt runs along the mid-oceanic ridges. Again, this is located underneath the ocean. To be specific, the Atlantic Ocean. It is a long underwater mountain chain that extends from the Arctic Ocean on the topmost portion of the globe and close to the southern tip of the South Africa. The intensity of most earthquakes here is moderate. The world was shocked by the destructiveness of the recent earthquake and tsunami that struck Japan. But this one is part of the Circum-Pacific belt. These are just additional info. So that's all for today. If you have any question, just do message me on Google Hangouts, or directly you can message me through our Google Classroom. So that's all for today, class. Goodbye and thank you.